Welcome to No Diagnostic Required, a monthly look at what's happening in the world of C++, with me, Phil Nash, and my co-host, Anastasia Kezakova. Anastasia, how are you doing this month?
Good. Oh, actually got my second dose of vaccination today. Hopefully hope to do much better.
Excellent, that's great news. So you'll be fully vaccinated in a couple of weeks?
Yeah.
I think it's the standard process. Yeah, I'm halfway through waiting for mine. It's a bit of a longer wait here in the UK, but we're getting there. So hopefully things will be getting back to normal in the near future. Talking of getting back to normal, I mentioned last time we've got building works going on here where I am. You can't really see in my background, but I'm in a different location today because my office has been taken down and it's going to be rebuilt into a new studio in the near future, hopefully. So that'll be nice to get that over and done with. Finally get back to a fairly normal life, I think.
Will you show us the new location next time? Or maybe
I'll think about it. Maybe I'll have to put it in a slide. Okay, well, let's get started. I know you've got a few things to get through first of all, so I'll put the first slide up for you.
Yeah, thank you. Let's talk about that. So if you're contributing or just playing with LLVM or Clang, you should definitely know the answer, like how long does it regularly take you to build the LLVM monorepo? And so on some very large machines with more than 100 cores, the result might be something like 2 minutes and 30 plus seconds, which is good, but it's really a very powerful machine that should be there for this result. So what if I say you can do this in 80 seconds? So sounds unrealistic, yeah? But wait, let's get into the trick. And the trick is actually in this article. So for this trick, they are actually using the tool called Llama. I think it's something from Lambda, because it's actually a tool for running Unix commands inside of Amazon Lambda. So you get this compiler as a replacement for GCC and Clang to execute a compilation in the cloud. And so you just substitute a compiler with it, and you can build using Make or similar build system with a much higher concurrency number that you normally have, like somewhere around your number of cores, less. So how it works, as far as I got from the article, so it runs the preprocessor locally first to discover all the header files required by that source, then uploads every source file to the cloud, invokes the Amazon Lambda function with the specific runtime, so it gets the header, it compiles with inside this Lambda function and uploads the results back. Then the results just downloaded to your local machine. So this is just pure magic, built on top of the very regular process, I would say, like the Amazon Lambda process is kind of very default for many people today, I guess, in the development. So there are some caching things to avoid repeatedly uploading or downloading the same files. And actually in this article, the author is using this tool for building the LLVM. And that's what gets the magic. That's what brings the author to this magic, I would say, of 80 seconds. Really impressive results. And there is a price calculation because that's the cloud. It costs something. And actually the cost is not quite high. And this is incredible. So with a very little cost to actually get a great result. So if you want to optimize further in case of specifically LLVM, there are a few more tricks discussed in the article there. Interestingly, the LLVM build time seems to be affected by the issue in the CMake Ninja generator, which is kind of locked in their issue tracker so that it omits some necessary dependencies of add custom command. So that's just a bug, but it actually affects the build times. And also the author suggests that some really long files in LLVM can be actually splitted into smaller batches just to benefit from the parallel build in this case. So yeah, I would actually like to learn more pros and cons here. Probably I'm missing something, but there should be something going wrong, I do believe, but I can find them. So if you see something, just would be great if you share with us, and we'll be happy to discuss actually. But yeah, that's all about this article. Let's move forward.
Definitely something, before we carry on, that's definitely something I've experienced in the past. I know many people in the C++ community have done with long build times. Previous job I had, we had over an hour for just a single build, and if you wanted to do debug and release and other variations, you'd have to wait hours. Now we were using Team City, and that helped us to split split them out at that level at least. But we even found that using Incredibuild across all of our Teams machines didn't help, because there was just so many files that the I/O started to become an issue. So we weren't even able to use Incredibuild to get us out of it. So yeah, maybe putting it all up in the cloud would have been a better option. So really interested to see how that actually pans out, if that's the numbers are as good as they sound in that article.
That's very interesting approach, I would say. So we actually paid our attention to this because, we're also building LLVM on Reaper. So I also have the CLion based language engine. So we're very much interested in how long it takes to build. So like we can build on our Team City and just forget about the times, do something different while the LLVM is building there. But if you want to build locally to do some quick turnaround and some checks, it's nice to know that there are these approaches, building quicker. So yeah, but just okay, let's move forward. So talking about finding bugs, address sanitizers. So it's always great to see how the real tooling is performing in the real world. And open source projects are just a great field to check this tooling on them. And Microsoft has added address sanitizers to Visual Studio quite recently, and they now published a blog post about this, digging into a few cases from the open source projects with this address sanitizer. And actually, they already caught one bug in Microsoft compiler and wrote a blog post about it somewhere in April. But you probably can't dig into, Microsoft compiler source code deeper to understand the conditions and check for the details. But with open source projects, you actually can, and that's very interesting. So, and I should say in advance that they are not just describing the problem. There is also a link to the commits with the fixes of the problems in GitHub, so you can see what was actually changed around these issues. So there are 3 projects in the article, 3 open source projects. One is Boost. So no surprise, a very interesting open source project to give a go for address sanitizer. So actually there was a problem in Dereference in the end iterator. The sanitizer detected it with global buffer overflow message. So they caught the bug, and there is a commit on GitHub with a fix. The second one is Azure IoTC SDK. So the same error, actually, the global buffer overflow happened there as well due to the incorrect size value passed to memcpi function. So if you look inside, you still need some effort to dig for the original error in this second case, but that's fine. So you just have this message that something is going wrong. You have the global buffer overflow issue, and then you dig further for the particular error. And the third one is the OpenSSL, and there is another memory access bug there. It's, in this case, caused by the assumption about the type sizes, which depends on the architecture of the program being compiled. So for example, in your code, you have several definitions for the type with different sizes. And in the code later, you make some assumptions about these sizes, and they're probably wrong because they are not always true, I would say. In some cases, they're true. In some cases, they're false. And in the case when they're false, you actually run into the trouble. So in memcpi or in other places. And that was the case for the third project for OpenSSL. So yeah, that's naturally the whole article. So if you're interested in any of these projects, just give it a try, look at the GitHub code and check the description for the issue, and maybe try the address sanitizers on your project, for example. See if there is anything in your project which it could actually cut. I'm not sure, Phil, how do you feel about the address sanitizer? Do you feel it can cut some reasonable bugs for us?
Well, yeah, I mean, in a way, the worst thing is if you run it over your code and it doesn't find anything, because then are you really sure that it ran at all? I think that was something that came up on Vcpkg recently. But I looked at the Boost example. I didn't look at the other ones. And one thing that struck me was they gave a simplified example just demonstrating the type of problem, and then they showed the Boost code. And in the simple one, you think, oh, I'd never write a bug like that. That's obvious. And then you look at the Boost code and you realize, actually, yeah, this can come up in much more complex situations where it's not obvious just by looking at the code. Even if you're an expert, looking at that code, can't necessarily say that the problem's there because it depends on so many other things outside of your immediate field of view. And that's one thing I'm actually quite hot on, is trying to write code in such a way that you can apply local reasoning. So you can reason about code in isolation. But of course, that's not always possible, especially in such a low-level language as C++. So having tools that can do that work for us is, I think, indispensable, really.
Yeah, and actually I would say what you said about the simplified example, that's true. And that's why I said that the open source projects are actually a very good field to play with, because when you're playing with artificial examples, sometimes you don't understand the value of the tool. But when you take the open source project and you can actually run the tool on this open source project, and then you see the actual problems revealed, and like, yeah, in this example, you can even go to the particular fix and to see what was the code about it, like do some digging, and then understand the real value behind the tool. So like do and check if you can catch the bug without the address in the same location. Yeah, that's true. Absolutely. Okay.
Right, well, one source of bugs is dereferencing null pointers, so maybe that's a good segue into the next one.
Yeah, actually, this is coming from the Jonathan Baccarat blog, and I would say that I really enjoy all the practicality coming from Jonathan Baccarat's post and talks. They're just fantastic. And this time the post is like, it's very simple and I would say short, but do check it. It's about the default value to reference null pointers and how it's structured. So you first look at the optional, and you probably know that optional t is an object that can have like all the values of t and +1 this special value as to the null option. So if you have to return the value from some function and like to provide some magic constant, let's say in case of the null pointer, like in case of the null, you can easily check that and in the if clause or in the ternary operator. But also the optional actually provides this value or member function, which you can use, and it allows to pack it nicely. So you can say like function f point value or, and then the default value you want to return in case of the null. So the question was actually, can we wrap the operations with pointers in the same way? So when we have to check the pointer, if it's null, and like if it's null, returns different. So you definitely can do the member function, but you can do a free function. And so Jonathan actually is drafting this value or function for pointers. So just a free function. And then he also discusses what would be the actual return type, which is also an interesting discussion there, but I will leave it to the listeners and to the readers just to check this explanation. So yeah, just go and check. That's an interesting part of how you can apply one concept from one thing we have in the language to another one, which is kind of different, but similar in terms that it also has this null value. So, and if you can implement a very similar approach, just in a very, I would say, similar area and handle these like classical issues, let's call them that way. What do you think about it?
It seems like a small, simple thing, but it's one of those small, simple things that when you apply it consistently, really makes a lot of difference, because the code just reads much more as you would expect, and you can understand what's going on. And one thing that struck me about this was you mentioned that you can't write it as an operator on a pointer, which of course you can't. Other languages have this functionality built into an operator, usually called the coalescing operator, often like 2 question marks, or there may be other annotations. It's a shame really that we can't overload additional custom operators in C++, although there's some good reasons why not as well. But if we could introduce something like the coalescing operator, then we could write that as a free function, but then we'd apply it in an infix way that would look much more like a method. So it's a shame we don't have that, but this is like the next best thing that we can do. Now, that's on pointers to model std optional, although of course std optional itself models pointers, so it sort of comes full circle. But there are some other piece of functionality that you might want to apply to optional that you can do with free functions. Be nice to make them methods. And that's actually a good segue into the first item on our standards news section. So one of the papers that's been going through for a while now, looks like it's just being dusted off, ready to go into the draft standard, I hope. Monadic operations for std optional. So it's a set of operations, map, and then, and or else, which are called the monadic operations. So if you understand monads, you'll know exactly what they are. And if not, it doesn't matter. You just have to know how to use them. And they just allow you to sequence bits of code together so that they compose regardless of whether, in this case, an optional has a value or not. So you can say, well, if it has a value, carry on to do this bit of code. And if that has a value, carry on to do this bit of code. But you don't actually do the conditional part in your code. So it looks like linear code. You're only concentrating on a happy path, and it shuffles the error or the empty path off to the end. Very much like we do with exception handling. So it's no surprise that this is often sort of considered as an alternate way of doing error handling, at least with optional. And we mentioned last time with stood expected, which is also still going through the standardization process, that this same set of operations would apply to that as well, specifically for error handling. So it's nice to see that stood optional is still being worked on. That there's not that much that's gone into this particular revision of the paper, so it's been around for a while now. So it's reassuring in a way that it is just these little things that are being tweaked, ready for it to go in, hopefully. So I'm quite optimistic about that. Any thoughts on stood optional?
Yeah, actually, that looks pretty cool. I would say that I personally not very big fan of all these Monadic approaches. I'm usually afraid of them, but I understand that the code looks much simpler. I mean, like, it looks nicer, it reads better. So that just may be a matter of hooking the code properly, which is sometimes a bit harder. Yeah. But yeah, the bringing these things to the language, actually given the ability to write the code in this way, would be great. I would say, like, yeah, why not? Let's do that. Let's make C++ different.
Of course, and you have the flexibility. You don't have to use these additional methods. You could just use conditionals instead. But there comes a point where that doesn't scale very well. And if you want to make this approach look more like exception handling, that's a good way to do it. Unfortunately, C++'s Lambda syntax doesn't help here. The overhead of the syntax itself gets in the way a bit, but you get used to it. But talking of alternate forms of error handling, that's been an ongoing area of interest for me for a while. And one part of that, which often comes up when we look at things like error codes, or even using stood optional or stood expected on the return channel to signify errors, is how do you make sure that the error is actually checked? And using optional is better than a pointer in that respect. But even better still is using nodiscard. So we've had that for a while now, the attribute that you could apply to a function to say, well, if you hadn't actually looked at the return value, then you can issue a warning. So implementation is not required to do so, but obviously encouraged to. So it just makes the, first of all, makes the code a bit more readable in that you can see that you're supposed to consider the return value. But if you don't, hopefully the compiler will actually warn you about it. That all sounds great, but it's not being widely used in the standard library itself, partly because it's been fairly new. So there's been a big push to get nodiscard applied to the whole of the standard library where appropriate. And this particular paper is talking about it in the context of iterators and ranges in particular. And there was some part of this paper that explained why it didn't go into 20, because it was discussed in the context of going into 20, but it came very late in the process. I think it was a national body comment. So at that point, it was considered that there were some open questions about it, and we can add it later, that sort of thing. So it was pushed back. This is the paper that's now following up on that to say, right, now here's our chance to get it in. And the thing about nodiscard being an attribute is, so first of all, the compiler's not actually required to issue a warning, but you're also not necessarily required to include the attribute in the implementation. So even if this goes into the standard, library vendors in this case don't have to put it in. So that gives a nice, interesting bit of flexibility there. And in fact, conversely, some library vendors have been putting them in, even though they're not in the standard. They're allowed to do that as well. Because it is just something that may issue a warning, doesn't change the functionality of the code. So it seems like a no-brainer to put this in to make sure that we're library vendors are encouraged to write them. They should do, and we should get warnings about these things, because there are many places in the standard library where the whole point of making a call is to get the return value. But the way the function is named, it may look like you're actually expecting a side effect instead. And some bugs have crept in as a result of that. And I think empty was one of the examples given in the proposal. If you call empty, is that clearing it, or is that telling you whether it is empty? And if it's no discard, it makes it much more obvious, even if the compiler doesn't issue a warning, that you are supposed to consider the return value. So they're making a distinction between those two cases. It's only if the function is essentially pure, doesn't have any side effects, and the return value is the main artifact that you're looking at. So I'm really in support of that. Glad that they're finally getting to do that, at least in pieces. Any thoughts on that, Anastasia?
Yeah, I'm just wondering, because I see that they say that not everything should be marked with no discard. They're gonna discuss that. Wondering, so what exactly would be the criteria and how they gonna decide what to mark and what not to mark? That's probably one of the most interesting questions here.
It is, and that's actually one of the reasons why it did get pushed back from 20, because there are some obvious cases at the extremes. Let's say anything that looks pure, like the whole point of it is to get the return value, and there are no other side effects. Obviously, you should make it no discard. Things that return void or return something that you may or may not check, and it doesn't matter that much because you're only interested in a side effect, don't put it there. But then there's a whole sort of raft of things in between, many of which involve generic code where actually it depends on other conditions as well. It's not always obvious. And one of the examples given was customization point objects, because they are, well, by definition, customization points. They're not necessarily provided by the implementation itself. You don't always know at that point whether that return value is important or not. And they have an approach to handle that now. I forget what it is off the top of my head, but it has now finally been considered. That was one of the things that held it back during the national body review before, that they didn't want to address it there and then. So yeah, they are asking those questions. You'll have to read the paper now to to find out exactly what the approach is.
Yeah, I would predict some hard discussions here, like to put or not to put no discard to some specific thing.
But again, because you don't have to get it 100% right. You are on the side of safety. It's better to have a few of these in than too many, or not at all. So
yeah, maybe just to play safe and to put to some obvious places, and just then to leave it as it is, at least for now.
Yeah, exactly. So that's our second somewhat error handling related proposal. That's why I picked these, by the way. The third one is pattern matching with exception handling. So pattern matching has been going through for a while now. It's a fairly big, ambitious proposal. So it's going to take a while to get that fully baked. I'm still not sure if that's going to be 23 at this point, given how everything's slowed down. But this is more of an auxiliary paper to say, well, pattern matching is all very nice, but with these different approaches to error handling involving return values, pattern matching is quite a good fit for that, and it could be quite tempting to use the pattern matching syntax for error handling. In fact, that's what many other languages do. They have their own pattern matching syntax and optional or expected types, and they use the pattern matching to do the error handling itself if they're not doing it monadically. So it seems natural, but of course that hasn't really been the focus of the pattern matching proposal itself so far. So this is just a paper that's trying to address that and say, well, how is this all going to work together? And the key question that it asks is, if you mix the two things, if you mix error handling by part of the return type with exception handling, what sort of code do you end up with? And if you can see the slide, it's a little bit small because it's there's quite a bit of code there, but it does give some examples. I think they're slightly extreme examples to demonstrate the point, so do bear that in mind. But you have a number of catch blocks, or try-catch blocks, And then you have these inspect calls for the pattern matching in there. And they're sort of self-similar. And that you've got a bit of code in the inspect, which could itself be a function call or a lambda. And then you have all of the cases for dealing with it, very much like catch blocks. So it almost seems like, well, maybe you could do one in terms of the other. And so the proposal here is to say that you can treat exceptions being caught as cases in the pattern match. So you can do inspect some call or lambda, and then in the cases for handling, you can have different types or values or patterns that may come out of that, or exception types, and they're just all in one linear list, which is exactly what you do if you were using error code or error type return based error handling. So it's definitely a consistency argument there. I think this is a fairly new paper, so I'm not sure if there's an opinion of it in the committee yet. I imagine there will be some resistance to it, but definitely interesting to see this sort of thing being considered. And if we don't get it, at least it has been something that's been considered along the way, and maybe other alternatives also proposed. So it's still very much the case that error handling is a big topic in the evolution of C++ at this point. I don't think we're going to see an end to that for a while yet. As I say, that's been an area of interest of mine for a while. Any thoughts on that?
Yeah, this actually looks very philosophic, I would say, but very much essential. Like, we have the pattern matching, we have all these discussions about the error handling, so how do they work together? I'm actually wondering, like, all this error handling story, how much of it is actually gonna come to 23? How do you feel about it? So you should probably know, or at least have some feelings about it.
As I say, I think some of the more ambitious proposals are not going to make it into 23, especially as some of them are proving quite controversial, especially things like P0709, my favorite one, static exceptions. That's not likely to make it into 23, if any. Whereas things like stood optional, the monadic operations we just talked about, or stood expected we talked about from last time, they've been mostly baked for a while, and they're not that controversial, that I've heard at least. I think it's just a case they didn't quite make the cut for 20, for time reasons. They're just being dusted off, tidied up a bit. They should go in almost like a checkbox item. So, stood expected, there may be a small amount of controversy, only in the sense that there are lots of other error handling techniques on the table right now that we're looking at. And if we go down the route of stood expected and then decide to adopt one of these other ones, especially something like P0709, would that just assume the whole need for stood expected? I think that's the only question really being asked about that, at least that I've heard of. So that may get held up because of that. I think the monadic operations on stood optional, there's no reason not to put them in that I know of, at least.
Yeah, I have a feeling here that with all these proposals somehow related to error handling in this or that way, we still don't have the full picture, so not everything is still on the table. So it's hard to understand what we should actually move forward, what we do maybe later. So not the whole puzzle is there. So we still are missing some pieces and we're still collecting all of them. I would like to see the overall picture here. This is our general approach, this is how we're going to proceed in these particular areas. But I still see all these, kind of separated papers around it, which kind of builds the picture, but it's not yet there. So, and that's probably what we're missing here for moving forward with it as soon as possible. I don't know. That just I'm not in the topic that deep as you are. That's just my feeling from all these papers that we're, still collecting very, very separate things.
Yeah, that's the problem. I think it's only really looking back after some time has passed that we'll see the error of our ways.
Yeah. Sure.
Yeah, so few papers that are relating to error handling this month. That there've been quite a few ongoing. I'm sure that's going to continue, and eventually we will get to the bottom of it, I'm sure. One thing that maybe we'll never get to the bottom of is ABI compatibility. That seems to have been getting a hotter topic again recently. There was an excellent episode of CPP last week, I think it was, as we record this, with Marshall Clow, where he talked about his take on ABI. And he did clarify that, that there are different things that are meant by ABI compatibility. And when we're talking about it in this context, we're talking specifically about things like memory layout and how the library implementations in particular differ from version to version in compatible or incompatible ways. But it may also impact things like calling conventions and other things that are less tied to the standard itself. But his take was that we really need to maintain compatibility. But one of the other things that's been coming up a lot recently is that, is that the right question to be asking? Is it more how we deal with breakage rather than whether we should break at all? Can we deal with ABI breaks in a way that actually allows you to maintain some level of compatibility? And there have been a few things about that over the years. Last year, we had the epochs paper, which unfortunately has been derailed a bit for now. At least I haven't seen that come back yet. That there may be a fatal flaw in that. But there's a new paper this month. Forget the name of it now, but basically talks about interface tags. And it's a way of versioning your types. So something you may not want to do for all of your code, although you can use it in user code, but particularly intended for the standard library itself, to be able to say, well, this part of my interface or this part of my data member layout in particular relates to this version. And then later you might want to say, well, I want to add a data member, and that's going to change things, or add a virtual function, which will also change the ABI compatibility. You could put that inside a different tagged interface block. And then as a user or a consumer of that type, you can say, I only want version 1 of this because I'm dealing with some legacy library that was built with C++20 or C++23. Whereas elsewhere in the code base, you might use the new type that has a different layout with extra features or better performance or whatever the thing is we wanted to change. And by default, if you don't specify anything at all, you'll get the latest version. If you ask for a specific version, you'll get that specific version. And then there's also other ways of doing things like anything from C++23 on, and that then has to fall back to a more dynamic binding. So this is how other languages often deal with this situation, is they'll use dynamic binding. Objective-C is a good example there. Every method call is a dynamically bound call that you can change at runtime. So they don't really have a problem with ABI there, at least not in terms of method calls or that sort of thing, because it's all dynamically bound. We don't want to pay the cost of that by default in C++, but this gives you an opt-in to say, well, where I need it, I can use that. And where I don't need it, I can still get the best performance and only pay that overhead for things that are actually needed. For example, converting between types from different versions. So it puts you in control. It's exactly the philosophy of C++. Don't pay for what you don't use. That doesn't mean never pay for it, and so you can never use it. If you need it, you need it, you can pay for it. And right now we don't have that ability at all. So I think this is a really important proposal. Whether this particular incarnation gets anywhere remains to be seen. It's got some big names behind it, so I'm hopeful it's going to get somewhere. But it may be it just sparks off other ideas and will eventually come up with a solution that everyone's happy with. But I do know that this is something that we absolutely need to address, because we are being held back more and more so by this inability to change things that are already baked into the standard. Do you have any thoughts on that, Anastasia?
Yeah, actually, I would say that since the very first paper from Titus, which is ABI Now or Never, everyone were mostly discussing like, these big twos, like to break or not to break. They were like one camp and another camp. And I would say that I clearly see that Marshall is not that happy of breaking the ABI. He did a great talk, actually. The CPPcast episode, I think it's just the short outline from what he did for the C++ Now as a talk on ABI, actually explaining why it's hard to break, like what's the problem, like because it's hard to detect, especially if you link dynamically, and so there is actually no way to detect properly, and all these things are kind of the reasons not to do it if you just want to break. But what I like more, and this actual proposal about the interfaces you're talking about, it has this pretty much important words like flexibility and ABI. So because it's about how to make these changes in a good way, how to make this flexible for in terms of these like breaking changes. And I've heard it for the first time about this proposal, why it's kind of not a new one, but I've heard for the first time about it in Bryce talk at C++ Now again, when he was talking about what to get into the standard library. And his main word was that before we get this proposal or something similar, like something similar to these interfaces to incorporate these breaking changes, we don't have to put a lot of things into the STL. So we have to be careful. We have to limit the scope and think about how to do this nicely with this kind of interfaces or whatever there is coming. So Bryce, we're actually analyzing, I guess, 3 approaches to that. 2 of them were before the interfaces, like the ABA tags, and there was something else I don't remember right now. So, and he was like kind of, giving points to how much they help to detect the feature, the problems, and to fix them. And this interface approach actually helps with all the issues he has in the table in the talk to detect and to fix. So there's a range of story behind this proposal actually. So, and I think that that's a good turn here in this discussion. So we have to stop discussing like to break or not to break, but rather think about how to do that in a way that it's practically usable for everyone in the C++ community, or at least for the majority. And this is just, maybe that would be not the final idea. I mean, the interfaces here, that exact proposal, but at least there is something which is more functional than just, the discussion on do or not to do.
Yeah. I think, to be fair, Titus's Now or Never was maybe a little bit clickbaity in its title. When that came up, that was fairly late in the C++ 20 cycle. And it probably was a bit too late to make a decision about whether to break ABI for C++ 20. But the question for future standards is really still left open. And we can't continue never breaking ABI. But one thing that was clear from the reaction to that was, for a lot of people, just arbitrarily breaking it is a no-go. So we need some sort of solution to, or some sort of approach to be able to ease that transition. And this is a great start, at least, in that discussion.
Yeah, sure.
So that's the standards news for now. As I usually say, this is all talk about proposals that are still going through the process. So none of this is guaranteed to actually make it in, just to keep us abreast of what's going on for the future of C++, hopefully. But coming back to the present, we've got some more tools news. Do you want to take it from here?
Yeah, let's talk about the tools which are very important for C++. I would say the dependency managers, package managers. So one of it is Vcpkg, and Microsoft actually announced that all the core features of Vcpkg are now kind of no longer experimental. So you can use them in your production environments, and that's what they say. Like, we're confident enough you can do that. So all these features are not new, like versioning, binary caching, manifests, and registers. So just to refresh on these features. So versioning allows you to rely on specific versions of the library. Definitely essential for the package manager. Like registries allows you to work with your like private libraries via the Vcpkg. Manifests allows this kind of shareable way of maintaining the dependencies automatically, like for MS Build or CMake projects. And binary caching allows you to actually reuse the pre-built binary via the VC package. So all 4 features are kind of essential for package management. And so they're not now no longer experimental. They're now kind of ready for production, whatever it means. But I hope that will be more stable. Maybe they have some more belief that they can really do a good job and they're not going to break them in some, breaking changes way. And along with the announcement, actually, Vcpkg started a new site and some updated branding. But more importantly, they now have an ability to browse through the available packages there for Vcpkg. And it searches like you just start typing the name of the package. It searches for the packages, showing you the list of matching packages. So you can type part of the name and shows you the versions, the platform compatibilities, which is very important, I would say, and the Vcpkg command to install the package. So if you're unsure, if the package is there, so what's the, the version, what's the compatibility in terms of the platform, just go to the site and check it out. We'll see it nicely. I think that's the best feature of this site for now, like this kind of a search. So yeah, I don't know. What do you think about it, Phil?
Well, I think package managers are really important. We should have as many as possible.
Yeah.
Well, we talked a lot about, we have mentioned Conan in the past. Vcpkg is the other big one in this field, but there's a few others as well. In a way, yeah, it would be better if we did actually get down to one standardized one. But I think more importantly, we're getting a bit off topic, but I know there has been more talk about having some standard protocol for package managers. Maybe we'll see something going in that direction in the future. But in the meantime, having Vcpkg have all these features no longer experimental, I think is a big step towards a much smoother managing of our dependencies, which is, as we know, one of the biggest problems in software development, at least for most projects.
Yeah, and interestingly about the standardization protocols, so Bryce actually was asked during his talk about the Astel about how he feels about, this package managers. Should we standardize one? Should we put one into standard? And the answer was no, let's standardize the naming scheme, the protocol, and let's have as many as we can. And that's good to have choice. They serve different goals, they serve different tasks, but the core thing should be kind of standard. And what I like around this discussion actually is that this question actually leads to the question of standard project model. And there was a clear answer from Bryce in the talk that he considers CMake to be the one. So probably CMake and ABI altogether were the 2 major directions for C++ now this year. But anyway, let's move forward to other tools in the package.
Yes, we've got this one, CLion. I don't know if you're familiar with CLion.
Yeah, I've heard something about it. Actually just recently started an early access program for 2021.2 for CLion. And it has an incredible number of CMake updates there. So we bundled the 3.20, but which is more importantly, and that's somehow related to 3.20, we actually have initial support for CMake Presets. What you can do now, you can actually call the specific action in CLion, which just load the preset for you into the CMake profiles we have in CLion settings. And so then you can use this profile loaded from CMake Preset. So it's still in read-only mode for now. So you definitely can go to the JSON file, which is the CMake Preset JSON file, and edit it, save and reload it. That's fine. But what I mean is that there are no automatic way to edit some specific settings in the CLion UI. We're still considering that. So if you have good thoughts on how it could look like, just let us know, give a try for the current build, and just share your ideas. So we're in the very beginning of supporting CMake Presets in CLion. But yeah, something is already there and you can try it. And if you have, for example, a project which has the CMake preset in the repository, so you can just grab it and load it for this project. So the process more or less works. Also talking about the CMake, there are CMake project templates, which means that when you're creating a new project in CLion, the CMake new project in CLion, these templates are used, and you can now edit them. So there are like cute projects in CMake and some others, and you can just edit them and add some specifics you have for your cases, maybe for the projects you are doing. Also, there is this lifetime analysis. So we're for a quite long time working on all the data flow analysis, all these things of catching detangling pointers and all the stuff. So definitely we are more into this lifetime now. So we've implemented some new checks based on Herb Sutter's proposal. So when we're trying to analyze the data and show these kind of warnings, there's support for GSL annotations. So if you're using GSL library to annotate the code, it will be supported now in CLion. So it will show these warnings if there are some issues coming out of this knowledge with the GSL annotations. Next, probably nice and interesting thing for those who would like to, prototype in C++ or who are just learning the C++ is the Clink interpreter support. So I probably never heard of it, but yeah, we have an interactive interpreter for C++, which is called Clink, and you can use it for prototypes, small pieces of code, or just to learn something about C++. Many of us probably is doing that, in Compiler Explorer, but now you can do that. Just write your IDE with the, full prototype, full interactive interpreter. So you need just to install the Clink, and just then you can start the Clink session in CLion. And which is more, there are a few actions in the editor you can use. So you, for example, can send an include directive to Clink, or you can send a particular line of code to the Clink session, or you can even select whole bunch of code and just send this selection to Clink session, and it will be passed to this session. So there are a few limitations, few things not working right now. We probably will be fixing them before the release, but it's ready for you to play with. So you go grab the build and check it. There are other things there improved, and a few enhancements, and some nice things like the text search, the local history. And if you don't know, like the local history is the thing that which actually saves you if you don't have the project under the version. And so now it has this kind of text search, so you can search for some specific things to get this particular time in the timeline, for example. So yeah, these are the major things. So just check the blog post, read everything in details, grab the free build. AP builds are free to use. So just provide us your feedback, and we'll be very happy to learn about how you feel about this. Yeah, so that's it about the CLion, I would say.
Yeah, well, it's always interesting to see what features come first in every new EAP. I'm particularly always interested in the like lifetime analysis and other checks. As I said earlier when we were talking about the address sanitizer, there's so many things that you can't really see when you're just looking at the code as a human. I think getting our computers that are really good at this sort of thing to be able to find these problems for us is really essential. So always have a few new things in every release that I always watch for. Okay, talking of JetBrains related things. So JetBrains were C++ Now sponsors, particularly for videos, and there's a big consequence of that. Maybe you want to take us through that?
Yeah, actually, this is the conference we really love, and we are the video sponsors for C++ Now for a while. And this year we came up with this early access to the talk recordings. So, the C++ Now 2021, so it was in the beginning of May. It was online, so fully online. No one was there in person, I would say. But it was not that many people actually there. So I think something about 200, I don't know the exact numbers, but like that. So quite many people are, I guess, waiting for the recordings. And so there are great talks. They were talking about these, breaking, not breaking, ABI discussions, interface proposals, the CMake things, the lots of things about the C++20, like the models, the concepts, everything was there. And yeah, the Bryce keynotes again, as I said, so on what should go to the standard library and how we should deal with this breaking ABI. It's a great thing. So if you missed the event, here is something for you to pay attention to. So together with Bloomberg, JetBrains is supporting C++ Now as video sponsors, and we're bringing you the early access to this year's conference recordings. So you can grab them at gbjj/CPP Now. And actually, the talks will be published in the official YouTube channel of the conference, just as regularly. But since they're now under procession, so the technical team is still working on them. So not all the recordings are still there. So, but we just grab the very first recordings from them and put them to this page so that you can watch through them, and you can go to this to them at YouTube. So that's just the same YouTube links, which will be available for the public later. But in a month, all the talks will be, there will be a huge release for these talks publicly in the YouTube channel on the conference. But for now, you can go and check this page where we'll be constantly adding new talks. I think there are something about 6 or 8 now on this page, or maybe a bit more by the time this episode is released, actually. But there will be more during the next month. So just keep an eye on the page. Maybe your favorite talk or the topic you're interested in will be there sooner or later. So just check them there. And yeah, talking about the conferences, actually, there are more conferences coming. The one which is not coming quite soon, I would say, but I would like to start with it, is the Meeting C++. They actually have announced the fully online format finally. They will be happening in November, somewhere in the mid-November. I don't remember days, unfortunately. But the thing is that as many other conference organizers, Jans is experimenting with the format. So his idea is to skip the keynotes this time and think more about some other non-standard formats for the attendees. But whatever he comes up with, the call for paper is open till the end of June. So yeah, if you have an idea, just go and submit it for the call for paper for Meeting C++. And another conference, which is coming quite soon, is C++ and C, actually, your conference, Phil. So it's in a month, I guess, from now. So, and the full schedule was announced. So yeah, that's a great lineup. And I would say that, again, a new format. So for C++ and C, just like first 2 days are 5 tracks of workshops. And the third day is the classical days of regular 1-hour talks. So, and you can see the program, and there are like great workshops from Nika Jositis, from Anthony Williams, from Claire McCrae, from many other people. And the talks are also great. Like there's Kevin Heaney, Mateusz Put, and so the closing keynotes by Barbara Geller and Ansel Sommerheim. So I think the lineup is actually great. Congratulations, Phil. I really like it. So hopefully I have to start preparing my half-day workshop right now.
I hope so, yeah. Yeah, you mentioned that many of us as conference organizers are experimenting with different formats. And I think I've already mentioned before that I was going to do this, bringing the workshops into the main program. And the consequence of that is that the ticket price is about the same as it has been previous 2 years for the full conference. But for that, you get 2 workshop days as well. So it's really good value for attendees. But there's a few more innovations as well going in this time. One of them is what I'm calling turning the schedule on its side. So the conference day, because we've got all of the talks on one day now. Normally we would have 3 or 4 tracks over about 5 or 6 hours. So about 3 or 4 slots plus a keynote. And the trouble is, of course, live, although you can watch recordings later, but live, you can only go to one talk at a time. So you're missing most of the content. So the idea here is that now we're doing it all online and people coming in from different time zones as well. We're making the day longer, so you have more slots and less tracks. So it's sort of turning it on its side in that sense. So 2 tracks, and then we've got 5 slots plus a keynote. So that's quite a lot of content. And if you can't make it all, if you want to miss a few, you'll still get the same number of talks that you would have done in the previous years. So you don't have to feel guilty about it. So particularly if you're coming in from another time zone, you have to miss the first couple or the last couple, that's fine. But if you really want to go for it, if you want to watch all of them, you could do that as well. The choice is up to you. And overall, there's, I think, more talks than on a single day last year. So it's definitely a different way to do things. I know that CPPCon, they always try to pack as much content in as they can, and they have stuff before and after, and they have some quite long days as well. Some of the material is optional, but yeah, this one is just straight talks, just for a longer period of time. Plus, we've got lightning talks on the Thursday evening, so before the main conference day, and we're going to be using a new hosting venue platform, which was the same one used at C++ Now, actually, Gather or GatherTown, which is also really interesting because it's more like a scrolling game almost. You have a little character that can move around, but it's built for interaction between people. So although you can actually even play aspects of it, I had a maze at C++ Now, and we're going to have something similar for C++ on C. I won't go into the details just yet, but you can have a lot of fun there. But if you just want to meet people, it's even more like going to a real conference where you wander around and you bump into groups of people talking about something. As you get closer to them, you start to hear them louder. So you might think, oh, yeah, maybe I'll come back and speak to those people later. They're not talking about something I'm interested in right now. You just wander on past. No interrupting a conversation and then dropping out again. And lots more that we can actually do there. There's all the interactive objects, and maybe you have to find things, or you can go to sponsor booths and interact with tables and things like that there. So there's a lot more there than you may have been used to at other online conferences. So do check it out. Check out the webpage, cpponc.uk, and hopefully we'll see you there.
Yeah, I really hope I will be able to check some cool talks, especially because my workshop is the first day. So I have big chances to check something later when I'm done.
Yeah, that's the trouble. If you ever get scheduled for the last talk of a conference, it's difficult to follow the rest of it.
That's
get out of the way early.
True. Yeah.
Right, well, that's all of our normal news rounded up for this month. We usually have an and finally section. And this month, rather than going outside of us, I've got some news to announce for our and finally. Now, this podcast or video, depending on how you're consuming it, we've always pitched it as being about community news, and maybe we'll talk a little bit more about JetBrains products just because we both happen to work at JetBrains. But it's, apart from some of the branding, it's never really been a JetBrains production. And that's going to continue to be the case because I'm actually leaving JetBrains. I'm going to be working somewhere else, and we're going to continue the show. Nothing really much is going to change because of what we just said. So in a way, that's actually going to make it even broader in scope. So, keep watching, keep supporting us, and we'll see where it goes. But hopefully it'll be fairly uninterrupted as I start a new chapter. And we will continue to talk about JetBrains products as well as others. So stay tuned.
You always have me. And I do hope Phil will bring some great new content here, which I'm not aware of. So
me neither,
would be nice to see the broader scope, definitely. But hopefully we'll still be able to continue and bringing you all the news from the community in the way we're doing it now. And if you have any suggestions, what you would like to learn about or to hear about, just let us know, and we'll take a look, and we'll definitely try to incorporate it into the next. And thank you, Phil, for working with us. Actually, it was 5 years, or I think
nearly 5 years.
Yeah, it was great 5 years. So hope you'll find something great in your future path, and good luck.
Thank you, and thank you everyone watching, listening, or just ignoring us and doing something else instead. And we'll see you next time.
See
Okay,
you.
bye.